Okay, so in this problem, I've rewritten the theorem right here. We're given this, and we need to deduce the double angle formulas for each of these. So what we're going to use first, we're going to write this as cis 2 theta. And then using this theorem, we can see that our n is equal to 2, and we know that our argument, or no, our modulus is just 1. And so we can plug in 1 right here, and we can say cis theta squared, plugging in a 2 for n. That 1 is redundant, and so we can just think of it like that. Okay, now from here, we're going to turn this back into this form, but we're just going to get, no, not that, cosine theta plus I sine theta squared. And if we do that, we're going to do cosine theta plus I sine theta times cosine theta plus I sine theta. And if we multiply those, we get cosine squared theta. Multiply these, we get plus cosine theta I sine theta. And then we get plus cosine theta I sine theta. So the same thing. And if we do this, we get I squared sine squared theta. Okay, a couple things. This is really -1, so we just get negative that. So our real parts are both these. So it's going to be cosine squared theta minus sine squared theta. And then we have 2 of these. So I'm just going to say plus I times 2 sine cosine. Okay. Now, if we just equate real parts and imaginary parts with, where are we? Okay, so we're looking at this. So cosine of 2, so right here is cosine of 2 theta, and this over here is going to be I sine of 2 theta. So we're just going to say cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So we're done with that one. And then this one, we don't really need to worry about the i's, so we're just going to say sine 2 theta equals 2 sine cosine. Okay, if you need additional help, please come to Math Lab. Until then, calculator.